Bismillahirrahmanirrahim. Now, inshallah, I will relate to you the last of the two theorems that we have in this chapter, and they also relate to the perpendicular lines. Now, thus far, we talked about three of them. We talked about the congruent linear pair theorem, where you're given a linear pair that's congruent, and then we just suggested that the lines were perpendicular. And then we said when two lines intersect, they give four right angles, and we talked about that one. And then we suggested that if two adjacent lines, if two sides of adjacent angles are perpendicular, then the two angles are complementary. So those are the three theorems that we have learned thus far. To complement that knowledge, so to speak, we have these last two theorems. And if you notice in these last two theorems, we have two lines, and it seems like a transversal type of thing, and that's precisely what they are about. So if you have two lines here, H and K, for example, and you have a third line that I have labeled as J previously, so I'll call it J. So I call this one the perpendicular transversal. I'm just going to call it T, special T. Let's call this T sub P just for the heck of it. Perpendicular transversal. This theorem says, and the emphasis here is on the P, the perpendicular transversal. This theorem says that if a transversal is perpendicular, if a transversal is perpendicular to one of two parallel lines, if a transverse is perpendicular to one of two parallel lines, so if it's perpendicular to this one, and these are parallel, then it's going to be perpendicular to the other one. That's what it says. Then it is perpendicular to the other. So what this theorem says, if there's a transversal that's perpendicular to one of the two parallel lines, then it's going to be perpendicular to the other one. So that's the theorem. So if a transversal is perpendicular to one of the two parallel lines, then it's perpendicular to one. And this is only true, of course, if they are parallel, right? So if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other one. Okay. Now this one is just as easy, but it's a little tricky. You have to be careful here and how you word this one. Okay. So let's call this one M and N. All right. So now this theorem is about the transversal. See. Now this theorem is not about transversal. This theorem is about these lines. Okay. So that's why they're drawn differently. So this theorem is about transversal. If a transversal is perpendicular to one of two parallel lines, that's perpendicular to the other one. Now this theorem states that if two lines are, they happen to be perpendicular. If two lines are perpendicular to the same line, if two lines are perpendicular to the same line, notice when we started, there's no parallel symbols anywhere. Okay, there are no parallel symbols anywhere. Okay, if two lines are perpendicular to the same line, okay, then they are parallel. So this is a kind of one theorem that kind of merges the perpendicular and parallel lines to parts of the chapter. So this is another way of proving lines to be parallel. Listen carefully. This is just another way of proving lines to be parallel. Notice we did not start out with parallel lines. It says that if you're given two lines over here, M and N, if they are perpendicular, if they happen to be perpendicular to the same line, okay, then they are parallel. parallel. So it's their perpendicularity, okay, that gives the parallel nature of the line. So the proof is suggested over here. They're perpendicular, and that means they're 90 degrees, 90. They're congruent angles, and those are corresponding angles. You can use the corresponding angle postulate converse to prove this, right? So these are the 5 theorems that you'll have learned in this chapter about perpendicular lines. First is the linear pair congruent theorem. We suggest that if 2 lines intersect to form congruent linear pair, then they are perpendicular. And this one says if 2 lines are perpendicular, then they give 4 right angles. And this one says if 2 adjacent angles, if 2 sides of adjacent angles are perpendicular, then they are complementary. And this theorem says if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other one. And this one says if 2 lines are perpendicular to the same line, then they are parallel. This is not a way of proving 2 lines parallel if they happen to be perpendicular to the same line. And this actually concludes the theorems in this chapter that are related to geometry. We have to review some algebra too for this chapter about lines and slopes, etc. We should do it some next time, inshallah. Until then, assalamu alaikum.